Okay, in this lesson, we're going to discuss coordinate geometry. So we've covered triangles, quadrilaterals, parallelograms, circles, polygons. We've covered all of the shapes. I'm going to go back just a little bit now that we've gone through circles and taken a break from polygons, and let's look at some coordinate geometry. So basically in coordinate geometry, we've got those two-dimensional shapes on a graph, on a coordinate plane. This is to get us ready for transformations, reflections, dilations, and that kind of stuff. So that's why we did this lesson after circle. In coordinate geometry, we are going to be classifying quadrilaterals by, and not just quadrilaterals, even triangles, by their characteristics. We're going to use the distance formula, and we're going to use other methods that we know and compare these quadrilaterals in a coordinate plane to figure out what they are. Okay? So you're even going to use the distance formula to classify those triangles. Let's review the distance formula one time. So the distance formula is x2 minus x1 quantity squared plus y2 minus y1 quantity squared, and that's the square root of the whole thing. So let's get our x2 and x1 in here. And that's the whole quantity squared. And we've gone over this a few times. It shouldn't be anything new. And you can put this entire piece into your calculator at once. So it's not really that difficult to figure it out nowadays because you have your calculator that you can use. But the distance formula is how you calculate the distance between 2 points on a coordinate plane. And that is the formula that you use. Remember, you number your points, number 2 and number 1. And you have to keep those in the same order. And if you have a negative coordinate, remember, it's just like the equation for a circle. This minus is part of the formula. So you have to put that there whether you have a positive or negative, and then you actually put the coordinate of your x, y. Okay, so let's look at some examples. What if we're told the vertices of triangle PQR are -4, -4, Q is -2, 4, R is 2, -4. And the first one over here was P. Okay, so we have P, Q, and R, the vertices of our triangle. And what we want to know is the perimeter and the area. I don't really know what PQR looks like right now. I could sketch it on a graph and get some sort of an idea. But if I just look at the coordinates of those, let's just go ahead and graph it. Kind of look at that for a minute because I need to know about how much room I need. Looks like that's in the middle. Okay. So let's put some, and it's a lot easier to put dots than it is to put lines. So I'll do the dots. I know that's not very common, but it's kind of hard to draw a little line with this software I'm using. Okay, Now let's put our triangle vertices on there. So -4, -4. About right there. -4, -4. And then we have -2, +4. It's going to be pretty close to right there. And we have +2, -4. So right there. And that's our triangle. That's probably actually over a little bit. Okay. Now let me just connect those and draw in the triangle. Kind of get an idea of what it looks like. There we go. It's just a little bit off. It's not an isosceles. It looks like that top point just is a little bit to the left. Now we can't tell any of that from looking at a picture. Never ever tell any of that. But what we can tell for sure is the length of this bottom side. Because we were at -4, -4, and that's our P. And then the Q is at, the R is at 2, -4. Q is at -2, 4. Now, if you look at that bottom point, one's at a -4 on the X and one's at 2. We can visually look and see that there are 6 units between those. We could count those up because the Y doesn't change. It's just a flat line, so that's 6. We just know that one. It's 4 on the left because we went 4 this way, and we went 2 this way, and 4 plus 2 is 6. So that whole bottom side of the triangle is 6. Now to find the perimeter or the area, either one, we're going to have to get the length of the other two sides. So if we're going to get the length of PQ, that's going to have to be in the distance formula. So for the length of PQ, let's pick one to make it number 1, and pick the other one to make it number 2. So we're going to plug this into our formula. So the distance is square root of all of this. X2 is going to be -2 minus X1, -4, plus Y2, that's the Y part of point number 2, and I numbered Q as number 2, minus Y1, which is the Y value of point number 1. And those are all squared. So it's the square root of all of that, and both of those quantities are squared. So we really just have to put this in our calculator now. Squared and a squared. So we're going to pop over to the calculator, and actually I'm going to put this in my calculator first, and I'll let you do the same, and then we can double check. I actually closed my calculator after that last video, and now I have to reopen it. So give it 1 second. It's loading. And I might actually be able to do something a little different here. I think I can get both of these on one screen. Yes, okay. Well, maybe not. That is not what I tried to do. Can't get both of those on one screen. So there we go. Get the whiteboard. All right, so on the calculator, we're going to put in the square root of so green button, x squared, left parenthesis, -2 minus negative. Don't forget, you have to use the little negative button down there by the enter key for that. So it's minus -4. Close your parenthesis, up arrow 2, directional pad to the right to get off of the exponent line, plus parenthesis 4 minus -4, parenthesis, up arrow 2. And then you're going to hit enter. Now, whoops, the daisy, I put something in there wrong. Hold on. -2 minus -4 quantity squared. Squared, let's see what we got. Let's try this again. My calculator's a little bit confused. There, everything off that screen. All right, second, square root, left parenthesis. I know you can't see what I'm doing. But I will show you this calculator as soon as I get it keyed in. I can't remember this equation long enough to key that in, so I've got to look at it. -2 minus -4, right parenthesis, up arrow 2, arrow to the right. Whoops, the daisy, it did not get my square in there. Plus left parenthesis 4 minus -4, right parenthesis, up arrow 2, enter. There we go. Now I will share that calculator screen. You can compare it with what you've got. So that's the exact keystrokes that you're going to use. So second function, x squared, left parenthesis. Use the negative button because it's -2, minus, use that dark gray minus key, -4. Close your parenthesis, up arrow, excuse me, up arrow 2 to get the exponent on there. Nope, that's the wrong thing. Up arrow, skip these 3 in the middle there. 2 to get that exponent. Directional pad to the right, plus left parenthesis 4 minus -4, right parenthesis, up arrow 2, and hit enter. So the distance is 2 root 17. Now you push your switcheroozy button on here to change that to a decimal. So 2 root 17, or 8.25. Now let's go back to our whiteboard. 2 root 17, or 8.25. 2 root 17, or 8.25. So this distance on this side is 2 root 17, or 8.25 if we want to estimate it. Okay? Now all we need to do is find the distance of the other one, because the point of doing this is to classify this triangle. No, it isn't. We're trying to find the perimeter and the area. Sorry, I forgot what we were trying to do. So let's get the length of the other side. We're going to have the perimeter. We're going to have to add all 3 sides up. So on this other one, on this QR side, let's use Q as point number 1, and R as point number 2. So we're going to have the distance equals the square root of all of this business. So x2, 2 minus x1, negative 2, quantity squared, so up arrow 2, plus y2, that's negative 4, minus y1, all that quantity squared. And so it's the square root of that whole piece. Okay, so let's get that into our calculator. And I'm going to get this in my calculator while I'm looking at it, and then I'll pop over and let you see it. So we have the square root of everything. So left parenthesis, 2 minus negative 2, right parenthesis, up arrow 2, directional pad to the right, plus left parenthesis 4 minus negative 4, right parenthesis, up arrow 2. Sometimes it's just harder to enter it in the calculator, isn't it, than anything else. And then we'll hit enter. So let me let you see my calculator now. Make sure that you can enter in there correctly. It's a good time to pause the video. This is the exact buttons that you're going to push on that calculator, and it's in the right order so that you can get that in there. So the distance, the length of that other side is 4 root 5. Again, if you need a couple of seconds to get that in your calculator and make sure you can do it, pause the video. And if we want it as a decimal, we could push the switcheroozy. So 8.94 or 4 root 5. 8.94 or 4 root 5. So we got 4 root 5 or 8.94 on that other side. Now, we can easily get the perimeter, and we can get it exact, because we are going to do 2 root 17 in our calculator, 2 root 17 plus 4 root 5 plus 6. Easy peasy. 4 root 5 plus 2 root 17 plus 6. Four root 5, 4 second root 5, arrow to the right, plus 2 second root 17, arrow to the right, plus 6. Enter. So the perimeter of that is 23.19. And that is an estimate, because those things don't come out exact. So the perimeter is 23.19. Now, if you wanted to leave it exact, you're going to have to leave it 2 root 17 plus 4 root 5 plus 6. That's the exact answer is what we put in. The fact that our calculator doesn't leave a root in there says that those don't combine. They don't simplify any more than that. But either answer is correct. So your perimeter is exactly 2 root 17 plus 4 root 5 plus 6. And it is about 23.19. Sometimes our roots don't combine, and that's okay. Or it estimated 23.19, and that's just one long equal sign right there. Okay? That's the perimeter. Now let's figure out the area. You remember the area of a triangle, the formula for area is 1/2 times the base times the height. Well, let's erase some of this and get us some room. We don't need this anymore. Probably won't need that right now. What we need to know is, what is the height of this triangle? The height of this triangle is from the top, perpendicular, straight down to the bottom. Well, we know that the top is 4 above. This should be easy to figure out because it's 4 above the very top one, and the bottom one is 4 below. That's a total of 8. So the height of this triangle is 8. Easy now, the base is 6, the height is 8, so it's 1/2 times 8 times 6. Set in your calculator the area of this triangle is 24. Not too shabby. So in this one, you're going to use more of the distance formula, and we just practiced the distance formula when we did circles, because we had to use the distance formula and the midpoint formula to find the radius. Remember when we had to take the half of the diameter? We used the distance formula back when we got the sides of quadrilaterals. We used the distance formula in polygons. So we've used it quite a bit. Now, another thing you're going to do in this lesson is, what about that Pythagorean theorem converse? Remember that? It's been a while. So the Pythagorean theorem said c squared equals a squared plus b squared when it is a right triangle. Okay, but if c squared is greater than a squared plus b squared, conditional statement here, then the triangle is an obtuse triangle. And the opposite of that, if c squared is less than a squared plus b squared, then it's an acute triangle. And we studied this right after the Pythagorean theorem. It's been a while, so it's just a little bit of a review. What if you're given the vertices of a triangle and you're asked to classify it? What kind of a triangle is it? Well, let's see if I can reuse this graph. It would be superb if I could. Okay, awesome. So our vertices, they've changed. We'll take this out of there. And we're going to move that up to the top. Put it right over there. Go. Area. Make ourselves some room. We're given 3 vertices, and these are the vertices of the triangle. So A is -2, 3. B is 2, -1. And C is -2, -5. Well, let's plot our triangle here on the coordinate plane. Let's graph it. So we're at -2, +3. That is about right there. Then we've got 2, -1. That is about right there. And we have -2, -5. right about there. -2, -5. We're asked to classify this right triangle. Well, the base of this is easy. The base is 8 because it's 3 above and 5 below. You can just look at your y coordinates. So we already know that this side of the triangle is 8. Now the hard ones are those diagonals. Well, let's look at them. How are we going to find the length of the side of the triangle? Hopefully you're already saying to yourself, oh my, we have to use that distance formula again. Yes. So we're going to make one of these number 1 and one of these number 2. Let's make this one number 1 and we'll make this one number 2. And we'll plug them right into that distance formula. So for that top side, the distance is the square root of all of this. X2, that's 2 minus x1, -2, quantity squared, plus y2, that's -1, minus y1, which is 3, up arrow 2. So it's the square root of all of that. Square root of that long piece in the middle. So we'll put that in our calculator, just like we did on the other ones. And if I'm messing up your view, I never know how it's going to look on the other end when I drag that screen over. Hopefully it's not changing. If it is, I will be right with you. 2 minus -2, right parenthesis, up arrow 2, plus left parenthesis, -1 minus 3, close the parenthesis, up arrow 2. That is exactly the keystrokes that you're going to push. Whoops, no, not those. I did not get out of the exponent line. That was a funny answer. Let's try that again. 2 minus -2, right parenthesis, up arrow 2. You have the directional pad to the right to get off of that exponent line, or you're going to get a really big answer. Left parenthesis, -1, minus 3, right parenthesis, up arrow 2. That is all squared. Then we'll hit enter. And now I will let you look at that, what we put in on the calculator. So the distance between those 2 points is 4 root 2. We don't need to do any estimation because we're going to try to classify this triangle using the Pythagorean theorem converse. So we'll leave that as 4 root 2. That is the exact keystrokes that you will push, exact buttons in the exact order. So if you need to pause it, help you with the calculator, go ahead. So 4 root 2 is that top side. There's 4 root 2. Okay. Now the bottom side, we're going to do the same thing on our distance formula. So let's make this bottom point be number 1 and the top point be number 2. So in our calculator, it's x2 minus x1. Well, x1 is still -2, so that didn't change. y2 minus y1, so y1 is a -5. The only thing that changed in our calculator was we're going to put a 5 in place of that 3. Should be easy enough to enter. So we're going to do second square root, left parentheses, 2 minus -2. 2, parenthesis, up arrow, 2, directional pad to the right, plus, left parenthesis, -1, -5, right parenthesis, up arrow, 2, enter. Uh-oh, minus -5. Thought something looked funny there. Knew something went haywire. Let's try this again. Second square root, in that equation, it's a -5, and I didn't put the negative. Remember how I told you always remember that, and I just forgot it? You have to put that negative there. Don't forget that. Okay, let's start it again. I love the distance formula. 2 minus -2, parenthesis, up arrow, 2, right directional pad, plus, left parenthesis, -1 minus -5, right parenthesis, up arrow, 2, and then hit enter. There we go. Now let me share that screen with you. And you can see it is the exact same for root 2. That's the exact keystrokes you would put in. I'll let you pause if you need help with that. So we got the exact same answer for this side. What kind of a triangle is that? That is an isosceles triangle. We do know that for sure. Now let's look at the length squared and see what we get. So c squared equals a squared plus b squared is what we're looking at. The square of the longest side, our longest side is our 8. If you don't know that, you could put 4 root 2 in your calculator and see if it's more or less than 8. So put 4 second root 2, enter, switch it to a decimal, it's 5.65. So the longest side is our 8. That's what we're going to use for our C. And we're going to put it in this converse right here. So we have 8 squared. Is it greater than or less than? We don't know. A squared plus B squared. So the A is going to be 4 root 2 squared plus 4 root 2 squared. So let's put that in our calculator and let's see if that is greater than or less than 64, because 8 squared is 64. We do know that. So we know right here is 64. We don't know what it is in the middle, and we need to know what that equals. So 4 root 2 squared plus 4 root 2 squared. Let's go see what that is in our calculator. So left parenthesis, 4 second root 2, directional pad to the right, close it up and square the whole thing. Plus the same thing again. Whoops-a-daisy, get off the exponent line, hit that delete button and back up. Directional pad to the right, left parenthesis, whoops, no, plus, left parenthesis, 4 second root 2, directional pad to the right, right parenthesis, up arrow 2, directional pad to the right to get off the exponent line, 64. Was it greater than, less than, or equal? It's equal. Both of them are 64. That's how you know it's an isosceles right triangle, because it came out equal. Since the square of the longest side is equal to the sum of the squares of the other two sides, it's a right isosceles triangle. Where's our right angle? You might be looking at my picture going, I don't see it. Here's our right angle. We did not even know that when we started. So it's a right triangle. Now, if they're greater than or less than, it's an obtuse or an acute. So let's take these same things, this lovely distance formula and the slope, and let's classify some quadrilaterals. What if we have a four-sided polygon, a quadrilateral, with vertices at 0, 2, that's Q, 0, 2, 6, negative 4, 3, negative 7, and negative 3, negative 1. That's our vertices. So let's remember what we know about quadrilaterals. Let's think back to the characteristics of quadrilaterals. So opposite sides are parallel. Parallel lines have the same what? What is the measure of the angle of a line? That's the slope. So we're probably going to be using slope. What about a rectangle and a square? Those sides are perpendicular. They form 90-degree angles, hence the definition of a square. That's going to be an opposite reciprocal slope. You can remember that from our slope lesson. We're definitely going to need the formula for slope. So slope equals, there's my fraction line. So the top of this is y2 minus y1. And the bottom of this is x2 minus x1. It's the same kind of general process as the distance formula, but we have a little fraction. So we're going to be looking at sides of a quadrilateral and comparing the slope to see, are they parallel? Are they not? Are the sides the same length? Are they different? And it's going to help you to graph this on a coordinate plane so that you kind of know what side you need to be comparing. So I am just going to estimate the location of these points because I just really need to know what order they're in. So 0, 2 is going to be about right here. 6, negative 4, probably about right there. 3, negative 7, maybe right there. And negative 3, negative 1, right here. So it's that kind of shape. This was Q. This was R. S. And T. All right, if this was a rectangle, then we would know QT would be perpendicular to ST, and we would know ST would be perpendicular to SR, and we would know QR would be parallel to ST if it were a rectangle. And then, of course, QT and SR would be parallel. But that perpendicular slope tells us right off the bat if it's a rectangle or a square or not, or it's just a parallelogram. So the first thing we need to do is figure out the slope of these sides or these segments. So we're going to do the slopes of QR. We're going to do the slope of RS. We're going to do the slope of ST. And we're going to do the slope of TQ. Give me just a little bit more space in here because we're going to have to put this formula for slope underneath it. All right, we're going to make a little table. So for QR, I need a point number 1 and a point number 2. So Q is number 1 and R is number 2. So for QR, we have y2 minus y1. So we have -4 minus 2 over x2 minus x1, 6 minus 0. We're going to put that in our calculator. Put it in like a fraction, use your N over D button. And what you're going to get when you do that is a -1. And I'll just let you pause and do that on your calculator. So the slope of QR is -1. Okay, I just want to put this right here by it. Slope equals -1. That's not the distance of that, it's not the length of that side, it's just the slope. Okay, RS. Let's say RS, we'll use R will be point number 2 and S will be point number 1. So RS. So we've got y2 minus y1, -4 minus -7 over x2, that's 6 minus 3. So we'll put that in our calculator. That is -4 minus -7 over 6 minus 3. That, when you put it in your calculator, is going to give you a +1. So RS, the slope is +1. Well, if we compare the slopes of QR and RS, are they opposite reciprocals? Remember when we're looking at slopes, if you will put those whole numbers, put a 1 underneath them. We did this when we did slope. Now, if you look at QR, if you flip the sign and switch the flip the fraction and switch the sign, do you get RS? Yes. 1 over 1 is still 1 over 1, and it's negative to positive. So this is perpendicular. Because those have a perpendicular slope, it means this is a right angle. For sure, that's a right angle. Now, you could come over here and see if QT had a slope of a +1. And then we need to know, does ST have a slope of -1 as well? So is ST parallel to QR? If ST is parallel to QR, then it's also perpendicular to RS. Okay, so let's look at that one. So for this, for S and T, we're going to use point number 1 and point number 2. So ST, just to find the slope, y2 minus y1 over x2 minus x1. And the slope of that is a -1, is it? Let's see. -1 is the slope. Yes. Put that in your calculator, you get -1. And if you wanted to write that as a fraction, it would be -1 over 1. So the slope is -1. That makes it parallel to QR. They have the same slopes. They're parallel. Look here. ST and QR are parallel. That means I could draw in my little parallel notation arrows. I know they're parallel. I just proved it because they have the same slope. Well, if those are parallel, guess what? This is a right angle. I don't have to question that now. I know it. Now we just need to know about QT. Is QT parallel to SR? Do they have the same slope? Is this slope a +1 as well? If it is, then we kind of know what kind of shape we've got. Okay, let's go look. Whoops, daisy, erase something extra. So for TQ, we'll use point number 1 and point number 2. So it's y2 minus y1, -1 minus 2 over -3 minus 0. That's going to give you a +1 for slope. Yes, they are parallel. This is also +1. So you have opposite sides are parallel, both of them, and you have right angles everywhere because they are perpendicular. We definitely have a quadrilateral with 90-degree angles. Opposite sides are parallel, both pairs. So that's either a rectangle or a square. Now, a rectangle or a square, the difference is the top and the sides would be different lengths. If this was a square, these two would be the same length, as well as this one and this one. All four sides would be the same length if this was a square. If it was a rectangle, one pair of those would be longer than the other. Well, I'm looking at this and I'm thinking that this is probably the longer side right here. And this is probably the shorter side, just by the way I graphed it. So let's do the distance formula. And let's see if these are the same length or not. Again, it doesn't look like they're the same length, but you cannot tell by your eye. You've got to do it. So we're looking at the distance or the length of the side QT. We've already got it marked, 0.1 and 0.2, so we're going to use that square root. So the distance equals the square root of all of this. So x2 minus x1, so -3 minus 0, quantity squared, plus y2 minus y1, -1 minus 2, quantity squared, and it's the square root of that whole piece. So go ahead and put that into your calculator. See what you get. -3 minus 0, up arrow 2, directional pad right, plus left parenthesis, -1 minus 2, right parenthesis, up arrow 2, directional pad to the right. And when you do that, you get, whoops, the daisy, what did I push? Oh, forgot to put my parenthesis in there. Okay. I got 3 root 2. So I have not a negative. I did it wrong. I didn't get my negative. Let's try this again. Second function and then the square. left parenthesis, -3, not a 3, but a -3, minus 0, right parenthesis, up arrow 2, directional pad to the right, plus left parenthesis, -1, minus 2, right parenthesis, up arrow 2, directional pad to the right. Enter. What did we get? 3 root 2 is what I got on the second one. Now we could compare that. I'm just going to look at my points and make sure. -3 minus 0, -1 minus 2, -3 minus 0, -1 minus 2. Yes. So 3 root 2 is what I got for that one. Now let's do the other one. So the distance equals square root of, what points are we using on this? So I'm going to look at that top side, QR. So if I'm using QR, I'm going to say Q is point number 1 and R is point number 2. So distance is x2 minus x1. So 6 minus 0, quantity squared, plus y2 minus y1, -4 minus 2, quantity squared. All of that is the square root of that. So let's plug that in the calculator. See what we get. If they're the same, we must have a square. If they're different, we must have a rectangle. Left parenthesis, 6 minus 0. Oops, 1 second. Left arrow. Nope. Whoops, the daisy. There we go. Whoops, no. Plus -4 minus 2. Left parenthesis, -4 minus 2, right parenthesis, up arrow 2, directional pad to the right, enter. And on that one, I got 6 root 2. So one of them I got 3 root 2, and one of them I got 6 root 2. They are clearly not the same because this bottom one is 6 root 2. We have a rectangle. There's no sense in finding the distance of the right side and the bottom side because those are 90-degree angles. They have to be the same because it's 4 90-degree angles. So it has to be the exact same length. That is definitely a rectangle. So you're going to use slope, distance formula, converse of the Pythagorean theorem, all of the things you know about quadrilaterals, their characteristics, and you're going to put all that together, and we're going to classify and figure out things about quadrilaterals on a coordinate plane. Most of this is distance formula. Although it's going to take a while, it's great practice because you need to be really good at using your calculator and you need to really understand the distance formula anyway. Okay? All right. Remember, and on this one, you've got a lot of work to show. So the first step is notes from this video, handwritten, uploaded, a picture. The second step is show all your work on paper and upload a picture of that. You have got to use homework help. If you're at all struggling, you have to use homework help. Make sure that you get these correct with the assistance of a live tutor. And then the last thing, you're going to put your multiple choice answers into the Google form. Okay? All right. Good luck with that. I will see you in the next lesson.